Hello, welcome to Stat C1000. My name is Ray Lapuz, and we are doing some problems from section 8.1. We're dealing with confidence intervals, and so a couple of things are other objectives in this section are working backwards, where if you're given a confidence interval, you have to find a couple of things, and then finding the sample size n for an appropriate confidence level and an error bound that you might want to impose. Okay, and so the formulas are not too difficult, but we do have a calculator involved here where you can just plug in numbers and then you'll get your results quite easily. So you can obtain this by clicking on this link and or link below the video if you're watching this from YouTube or in our class. So this is the calculator formula. There's several tabs here. So the second tab is going to be 8.1 working backwards, and then the tab after that is called 8.1 determining sample size for the mean. All right, so I'm going to go back to the second 8.1 if I can. And then we'll take a look at how to do these things. So I think you need an appropriate size window here for these tabs to work out. Let's take a look at the first problem. An American community survey, part of the U.S. Census Bureau, conducts a yearly census similar to the one taken every 10 years, but with a smaller percentage of participants. The recent survey estimates 90% confidence that the mean household income for U.S. falls between $69,720 and $69,922. Find the point estimate for the mean and the household income, the mean household income, U.S. household income, and find the error bound. So let's see. This is the scenario that we have. We have an interval that has 69,720 and 69,922. So it turns out that the point estimate is going to be right in the middle. This is going to be your point estimate. And then the EBM, the error bound for the mean, is going to be a distance from the middle to one of those endpoints. And the way this is constructed tells us that both of these are equal, so you could just find one or the other. Just to give some formulas, the point estimate is literally the middle, the average between two numbers, and you can take average as a mean or median. So the point estimate is going to be equal to, well, the average between these two. You can add them. So you can add the min number plus the max number, and you divide it by 2. So that's easy enough as a formula. And then your EBM is going to be, if you take the distance between this, between the largest and the smallest value, and then cut that in half, then you'll have the EBM. So it's going to be the max value minus the min value. This time you're subtracting, and then you're going to, the max minus the min is the whole distance, and divided by 2 will cut it in half. All right, so let's introduce ourselves to this calculator. Here is our calculator. And all you have to do is put in the max and the min for your interval, and then it's going to do those two calculations for you. So 69.720 is the first number. 69,720. It's not point, sorry. It's 69,720. And then the minimum was 69,922. So the next number here is 69,922. Oops, too many 2's. There we go. All right, and if I press enter, I'll see that the middle of that value is 69,821, and then the error bound is 101. So in our calculations, we got the error bound to be 101, and then we got the point estimate to be 69821. And I suppose we should put dollar signs here because they are in dollars. And you can double check that. If you add 101 to the point estimate and subtract 101 from the point estimate, you're going to get those two endpoints. Okay, that's one part. The next part of the problem is looking for the sample size. So let's take a look at this problem. In this problem, we're saying that the average height of a young adult male is normally distributed with a standard deviation of 2.5. Okay, you want to estimate the mean height of students at your college or university to within 1 inch of the 93% confidence. So to remember our formula for the sample size, it's like going backwards from the EBM. The EBM is like z sub alpha over 2 times some other stuff, times sigma divided by square root of n. So if you work backwards to solve for that, you're going to get z sub alpha over 2, and then you're going to get sigma, and then you're going to divide it by the error bound for the mean. And then you're going to square the whole thing. So I think the textbook has each of these three factors being squared, but if you just do this computation where everything's there, and then you square everything instead of squaring each one individually, then it's going to give you the same result. All right, so we need a couple of things. The easiest to find, or the first to find, is the standard deviation here. So let's say sigma is equal to 2.5. The next is this statement that says within 1 inch. So the phrase within, or with an error that's less than or whatever, those are your key phrases for the error bound. So the error bound for the mean here is going to be 1. It's just the number 1. And the only other thing we need is z sub alpha over 2, and that is dependent on your CL, your confidence level. Your CL is going to be 93%, and so we're going to need to figure out what our z sub alpha over 2 is equal to, and then this is going to give us our n after we do the computation. So again, you can do this on your own, by yourself, with a calculator, or why not just use our ready-made built-in calculator. So this is going to be the third tab here, 8-1 or 8.1, determining the sample size for the mean. Let's click on that. You can see that it wants the error bound, it wants the population standard deviation, and the confidence level. It calculates the z sub alpha over 2 for us, and then it calculates the sample size. But remember that the sample size, you want the sample size to be a whole number, and so your final answer will be rounding up. Now we always have to round up in this particular scenario. Okay, so let's take a look and let's put in those values. EBM is 1, sigma is 2.5, and confidence level is 93. So EBM is 1, standard deviation is 2.5, and this is going to be 0.93, and then I press enter. So they calculate the z sub alpha over 2 for us, and they calculate the sample size, and remember you always want to round up, so instead of 20.5 we're going to say 21. All right, so just to make a note, this is 1.811 or 12, it's 119, so z sub alpha over 2 round off to 3 decimal places will look like that. And then our calculation for n is equal to 20.518 19 if we want, but of course we don't want n to be a whole number, so n will be equal to 21, and that is your result. And that's how we use the calculator, and that's how we do a problem. Okay, good luck.